Hello, everyone. So this is our new, like the first meeting in 2018 about the Scala platform. And today's agenda is going to be it's very diverse. We have 3 items.
Our new, like the first meeting in 2018 about the Scala platform. And today's agenda is going to be
Oh my God. That was weird. Okay, I'm sorry. Anyway, so so we have 3 items in the agenda. First, we're going to discuss about the cross-platform proposal that Martin, wrote in Scala contributors. And then we will move on to discuss Scala JSON AST and some other things about the Scala platform that we will be more concrete about afterwards. So first, Martin, would you mind explaining a little bit about what your proposal was exactly about? Because there was some misunderstanding last meeting. Right. There were clearly lots of features that were underspecified. So today we have here Sébastien representing a Scala JS project and Dennis representing a Scala native project. So maybe we can pinpoint exactly what you meant. We can try to find some technical solutions, and then we can try to answer the question whether the Scala platform modules should be cross-built to all the runtimes that the Scala currently supports nowadays.
Yeah, sure. So outlining the proposal at first, then I feel that there's a problem with all of the things you need to pull in from the Java world, basically, for simple tasks like doing date conversions and stuff like that. And so the proposal is basically just a discussion, an open discussion about how or if we want to include those artifacts somehow into the platform. Yeah, that's a short version of it.
So you watched our last meeting, right?
Yes, I did.
Okay. So there was clearly there were some reactions from the committee, and there were also some unknowns. Would you be able to clarify a little bit on those, or would you be able to say exactly what we got wrong?
Well, yeah, I think the scope got much bigger than I originally intended. So there was a lot of talk about specifying APIs and deciding how to convert all of Java, basically the standard library, into Scala and stuff like that. And I had imagined a simple solution where you basically adopt the interesting parts of the Java API at first and make them available through the Scala API. So basically, just for instance, Java, the new time or date libraries, you could just expose those under the Scala namespace, but they could compile to Java on the Java platform. And by having them in the Scala namespace, implementers of other platforms that are not JVM native would have a clear indication of whether or not they had implemented all of the API. Since at that point, the Scala namespace would contain all of the dangling sort of the facade to the Java util dates, whatever.
You basically explain about how unspecified the APIs are for the different runtimes we have. How, if you're a developer and you just want to use a library for native, you just complain that it's difficult to find out which APIs are supported in native out of the box.
Yes. So, for instance, a lot of the dates, the 310 package has been ported to Scala JS, but there are some, I believe at least, there are some things that you can't do. I don't think you can do zone datetime, or maybe it's some other part that's not available. But there is no indication at compile time when you try to do those things, because you're basically linking to the Java artifacts. And so that's the user end of things. You can't really rely on native Java packages to be available, obviously. And on the other side of the spectrum is like the implementation sites. When you want to implement the datelib in Scala JS, for instance, all of it or a subset of it, to accommodate for all of the users' use cases. And that's basically, I think that's a result of not having those artifacts under the Scala namespace, because even if you had like just a subset of the features under the Scala namespace, you would know that those are supported. And if they're not supported, or if they don't work when you're actually compiling your JavaScript, for instance, then at least the implementers of the facade knows about that. They can see that they haven't implemented that part of the standard library in Scala.
Mm-hmm.
Does that make things any more clear?
Yeah, I have some questions, but I'm gonna let some committee members first go ahead and ask some questions. Do you have anything to add, Sébastien or Dennis, at this point?
I have lots of clarifying kind of questions, and like, yeah. I wasn't in the previous meeting, so I don't know exactly how much has been discussed before. So
you haven't watched the previous meeting?
No.
Shame on you.
No.
I actually did. So I mean, I have a few comments because so there are a few things that are worth mentioning. First, about this Java time thing. If you're concerned that us implementers of alternative backends are not really aware of what we need to implement and what we need not, I can assure you that we very clearly know what is implemented, what is not, what should be, and what should not be. In particular, about the Java time package, it's easy. It should entirely be implemented. There is no reason that it's not, that it's in, I mean, there is no theoretical reason that it's incomplete. There is also no reason that it should stay incomplete because the parts that are not implemented are not that useful. I mean, it's all useful. The only reason it's not complete is because no one has finished the port, but everyone knows that we need to implement the entirety of the Java time package. So this is a very clearly delimited API, whether or not it's in the Scala namespace or in the Java time namespace. It doesn't change anything. We know it needs to be implemented in its entirety. So this is one thing. With regards to what was also discussed in the previous meeting and also on this course, there is also things like the standard library, and for that I have already had discussions via GitHub issues and stuff with the Lightband people. That, in my opinion, where we need to go is a place where the standard library, Scala library.jar, is entirely cross-compiled. So if something is in Scala library, it needs to be supported on all platforms. Currently, that's really not the case. There are parts of Scala library that cannot be implemented, at least on JS. Like scala.sys is just never going to work.
Parallel collections, maybe?
Parallel collections, same story. So some of them have already been extracted out in separate artifacts, like parallel collections for 2.13. And there is a will, a collective will, both from the Lightband team and myself, to move out of the Scala, of the standard library, everything that is not completely cross-compiled with similar semantics. So that's another story. And then once you have that, it becomes much easier, because now you can say, hey, the Scala library first, it's the same on all platforms. And that, as a platform implementer, you are supposed to cover it all. And then everything else is the responsibility of libraries. So Java time, I mean, I don't implement Java time. I just don't have the time to do that. That's up to the community to do. So it's I mean, there are platform implementers, but it's important to realize that all we really guarantee is that we're going to support the standard library and not much more. So that is another thing. And
right. So the question in this case would be should the Scala platform also abide by the same requirements on the Scala standard library regarding cross-platform?
No, absolutely not.
Should we ask the implementers downstream, the library authors, should they like try to cover almost all the runtimes when possible to get their modules accepted into the Scala platform?
So for the Scala platform, I think it is reasonable to ask that a library supports the platforms where it can reasonably be supported. Like if you're going to provide a JSON AST and you're not going to support one of the platforms, there's something wrong. If you're going to provide an IO library and you don't support JavaScript, there's nothing wrong with that. IO on JavaScript is weird, and I've seen people who say, "Oh, but you can implement using the Node.js API, right?" Except that's not how Scala.js works. Scala.js doesn't compile to Node.js. Scala.js compiles to ECMAScript. And ECMAScript doesn't have any kind of I/O. So when you run on the browser or on AWS Lambda or in a robot, you don't have I/O. So Scala.js as such does not require Node.js and is not supposed to require Node.js. So saying you can implement Java I/O on top of Node.js doesn't apply in the Scala.js ecosystem. So no, my recommendation for the Scala platform is as follows: ask that reasonable platforms be at least investigated. I wouldn't even make it a strong requirement, but I would ask. And it would be a plus. I mean, if you have to compare between two otherwise equivalent library, well, that's one criterion you can use to decide which one you're going to pick, among others, of course. But it cannot possibly be a requirement that all platforms be supported. That's nonsense. That's
So Conrad wasn't present in our past meeting, but I think that he had some valuable insights into this. Would you mind sharing that with us?
Yeah, gladly. Happy to be online this time. So my main point is absolutely agree what was just said. And what is helpful really in these situations is simply maintaining a list, or however you want to maintain it, that, oh yeah, these libraries actually work on these platforms. And it's really up to the libraries that if someone has I don't know, let's use JSON as an example, because it's a good example for something that can be easily, hopefully, supported on all the platforms. And then it's that library's kind of goal and also responsibility to say, hey, yeah, we actually work on all the platforms. And as was just said, that's a good point for people to then choose the library if they care about that. Because many people will stick to one of the platforms, but if you know you want to use a number of platforms, then suddenly this becomes important to you and you search for a library that has this point. So rather than making kind of Scala take care of it, we can maybe kind of incentivize libraries to take care of it. And if it helps, maybe we can have some marker for it in the Scala index or anything to make it easier to find libraries that, oh yeah, I need one that works on native or something. So I think this is more helpful than making Scala bound to this entire thing.
Yeah. Or in the worst case scenario, when you try to use a library and it doesn't support like concrete runtime, when you try to link it, it will fail, right? So the worst case scenario, you will realize that you cannot do it.
Well, even better,
right.
Once the standard library is guaranteed to cross-compile, then if you try to even resolve a library that's not cross-compiled, it won't resolve. Like if I try to use better files in a JS project,
right,
resolve. So it's even before compile time. You cannot even build your class file.
Yeah.
Right. Nice.
So that's even better.
I also have a comment about this, like, let's create a forwarders in Scala namespace for Java APIs. I think not only the accept says it doesn't matter if it's done or not. I would say if it's done, it will actually have a very negative kind of impact. Because first of all, you have lots of code to maintain, which has literally no value if it's the same API. Unless it's like some kind of new API which was designed from scratch for Scala, whatever that means, in whatever like Scala idiomatic style, which is different from Java API, there is some value in that, arguably. But if it's just a forwarder, someone will have to maintain this forwarder, because JDK API definition is very well kind of maintained by the authors of JDK, and there's very little value in providing forwarders. I would say there's negative value in providing forwarders. It will just be a maintenance cost. It will give a chance, like for example, for JDK to move on and this forwarder not to move on for whatever reason, because then, for example, JDK libraries can be different based on Java version you currently installed. How are we going to do that with this forwarder approach? I really don't see any way for this to work, to be honest. It's like, it's reasonable to maybe like have some kind of community whitelist of what kind of JDK APIs are supported on which platforms, because this is reasonable. Like you can expect Java lang strings to be like almost uniformly implemented. Like for example, string.contain should always work no matter where you are. But for example, like weird stuff doesn't work on JS. On native, in theory, everything can work, but amount of time it takes to implement everything is kind of like big. So we'll never implement everything. We'll never, for example, implement XML APIs from Java because it's just there's too little value to re-implement it ourselves. Like stuff like I/O we actually do work on. It's mostly driven by community people, but there is some progress on getting like, so file I/O has been contributed by Scala Center, and now there is some community work on network I/O. There's some community work on actually on multi-threading and like parallel stuff, but it's all kind of rough. But the point is, native doesn't really have an issues like JS in terms of if something can be implemented, like everything can be implemented in theory, because there are no constraints. Like there are only like time constraints and complexity constraints, and essentially like for reasonable portable feel across platforms, you just need a whitelist of stuff that works everywhere, and you need to make sure that this whitelist is somehow enforced. Maybe I don't know. I think I've seen somewhere the idea of shared test suite. I think this is a very good idea. This is probably as good of an idea as I've seen in the discussion. Yeah, that's pretty much my point.
Yeah, I think that Conrad also mentioned in one of his comments like 2 weeks ago or 3 weeks ago that there is no value in just compiling to one concrete platform. You also have to test it. Otherwise, you cannot claim that you
exactly
are compatible with a concrete platform. So yeah, that's interesting. So does someone else have any points here? Like,
can I respond to some of the?
Yes, yeah, go ahead.
This is the first time I heard about like the core of Scala compiling to different platforms, and I think that's a good thing generally. I think one thing that's being glossed over here is that by supporting, like for instance, let's go with Java time again. By supporting that in the standard Java namespace, you kind of model up like the barrier between Scala and Java, right? So you have some support for the Java APIs, Java time, but as you said, like no one will ever implement the XML libraries because we don't want them in Scala. So there is no clear distinction like where the actual namespace that's supported by Scala ends. Sure, it can be documented and it can be like, you can always search for that information. But from the compiler point of view, if you write some program, say, and you're hoping, like wishfully thinking that you will have an easy time later on to compile it to JavaScript, you basically don't have an indication of whether or not it will actually work in JavaScript before compiling it or trying it out, maybe further down the line, where you actually have a lot of code. So that's like
that is also the Scala namespace, right? I mean, you might try calling, using even on 2.13 the Scala parallel collections, because you add it to your dependencies, and you didn't check the documentation, you didn't notice that not going to have to work on JS, and then later on you try to add JS, and then I cannot use the parallel collections.
Yeah,
there were Scala namespace nevertheless, right? So,
but then it will, if I understand correctly, that will be moved out into a separate module that you will have to depend on.
You have to declare it, but it's not because you declared it that you checked the documentation. And if you only add the JVM version so far, you only have tests for the JVM version, you won't notice. Just the same way that you don't notice that Java time doesn't work entirely on JS.
So fundamentally, Martin, you are complaining that Scala JS, or compiling to a Scala JS, to the JavaScript runtime or to native, is a second-class citizen here, whereas the JVM is like the first-class citizen and everything works for it, but like people will not realize that they cannot do, or they cannot cross-compile to the different runtimes until they have they have the need for it, and they will realize, I cannot do it because my dependencies are just too big and I cannot port this thing easily to something else.
Yeah, and even if you don't do like a late time down the line compilation to JavaScript or try to do that, if you start to look around for I need to do some formatting, whatever, and you will get a link to Java, like a Java library. You don't know if that's supported in Scala or not. Like a lot of the Scala platform right now, maybe not a lot, but there are some links down to Java, to the JVM classes underneath, obviously. So some things need to be supported by different platforms, because in order for parsing ints and stuff like that, those things go down into the JVM and use those classes. And if I'm not mistaken, that means that the JVM objects or classes need to be implemented in Scala JS as well to do, for instance, string to int parsing. Is that correct, or have I?
I mean, string to int is something you can implement in user space, right? In a platform independent way. But yeah, in this case, it's part of Javalong integer, and Javalong integer is pretty core to any JVM-like language. You just cannot not provide it, right? But some more tricky stuff, for a long time there was no big integer in Scala JS, for example. That was problematic because it was a transitive dependency of some part of the Scala library, so it was really annoying. But eventually someone provided it. But the very, very core things we will find in the platform, because there are transitive dependencies of the Scala standard library. Anyway, like integer the parse int .to int on a string, which is in the Scala standard library.
Okay.
But it would be nice if somehow we could convince Scala C to complain if you're trying to use a part of the JDK that is not supported on your platform. But this is a hard technical problem to remove the JDK class files from the class path that the compiler deals with.
Even if you have compile time support for this, it's not obvious because at some point there will be some library like supporting some concrete use case, and you need to update the compiler to say, hey, like this is okay. There is this library.
Technically, you don't have to tell Scala anything. You can just add an extra page that says what does the symbol mangle to? Do you have it on Scala JS++, right? Like it can be, like at least for native, I think it's imaginable to add this extra check class. I think it's not impossible.
So I wanted to reiterate the point about how much extra work it is to provide extra copies of interfaces. And not just, it's not just extra work for the library maintainer, it's also extra work when you go through reading the code. Because, for example, right now we have an array.copy method that does exactly the same thing as the java.lang.system.arrayCopy method. They're identical. And as you go, when you read through code, you see both of them, and they both need to work. And the Scala one is just basically a distraction as far as I can tell, given that we can't drop the support for the Java one. And so I think that the way to, so I think making many more cases like this is going to just complicate the reading of code. But I think the concerns that are being addressed are real ones. I just think that they need to be addressed by tooling in a different way. For example, if IntelliJ could have a mode where it would simultaneously be Scala JS aware and Scala JVM aware and Scala native aware, then you could get a pop-up that would say, I know there's no support for this in Scala JS, and you could configure that. Or if the ability to do cross builds with SBT or some other tool was made easier. I mean, the easier it is to set up cross building, the easier it is to just go along coding as you do normally and let the compiler of the appropriate runtime catch the things that you may not have noticed and yell at you.
Yeah, I totally agree that this is a nice use case for tooling. Probably this can be implemented somewhere in a tool, maybe static.
So,
right?
So maybe this has been said already, but I feel like this proposal is, or like the problems that have been outlined in the proposal are definitely real. But I think as much as we can think of solutions of how to solve them technologically, I think it's also more of a resources problem, because as Sébastien has said, there's not infinite time to implement all those APIs. So I'm always a bit wary to try to fix sort of like a resources problem with more technology. And at best, such a compiler phase could be a band-aid, saying, okay, you're using something that's not portable, but the actual fix would be to make it portable. And of course, this is where the community should step in. And speaking of which, I have a technical question, because I'm not very familiar with extending Scala JS. So let's say I would have time, or some other person in the community would have time to implement some Java API. Would that implementation need to go into Scala JS proper, or could it be supplied by an external library?
It depends. Well, first, if it is adding a method to one of the classes that are already provided by Scala JS core, but one method is missing and you want to add it, then you have no choice but to add it to Scala JS core. If however, you're implementing typically a bag of classes that work together, say the Java time sub-package, for example, we actually won't let you put it in the Scala JS core, because we don't want our CI to explode for no reason. So we actively encourage people to publish them as separate libraries. And typically the right call is to take as templates one of the other ones that we maintain, like Java login, which is a very small one. You can take the build from that one, copy it over, and it has support for implementing the Scala.js version of the library and having your test cross-compile against the original JVM implementation and your implementation to make sure that they behave the same. And it's not difficult to set up. It's just, I mean, it's a bit non-trivial but if you copy over the template, it's very easy. So usually, I mean, if someone even suggests like, hey, I'd like to send a PR with that ginormous API from Java, we're going to say no, please publish it as a separate library. Does that answer the question?
Okay. So I remember Bill also having some different opinion on this matter. Is that correct, Bill?
Well, no, I think what would have been nice if you were starting from scratch, you could probably make Scala API more like a platform.
Yeah.
That would have been nicer because it's really weird to go to Scala.js and use Java classes. That's just weird. But at this point, it's hard to.
Try printing an array. That's the best one.
Feeling. So, yeah. So. I think it's like
I mean, if you were designing Scala all over again,
exactly.
Then we would try to be a little bit more like Kotlin in this case. I mean, with regard to multi-platform, and yes, we would probably provide Scala-specific APIs for everything that is core and map it on the various platforms. We would have to make sure that they actually work correctly on all platforms and that they're really well supported. But anyway, that ship has sailed. There is just too much of the Scala ecosystem that uses Java, relies on the Java APIs. If we want to implement some efficient string operations, we're not going to use the Scala string builder, even though it exists, because it's too slow. We're going to use Java long string builder. So even when the APIs exist, we bypass them because they're too slow, and we use the Java ones. So we have to implement the Java ones in the other platforms anyway.
That's a separate problem.
Very specific, right? Like you need speed and this.
No, but not me. When I say we, I mean people. It's a very well-known problem that Scala collection string builder, you don't use it. It's too slow. So if that part of your program is in any way a little bit time critical, you use Java long string builder instead.
Yeah.
Right? Same thing for maps, right? Same thing for maps. Like mutable maps, if you care about them, like Scala maps are way too slow.
Yeah.
The other thing I was going to mention was like there's a proposal for opaque types.
Yes.
That would, if you really wanted to wrap the string builder in Java because it's fast on the JVM with the Scala one, then it's actually is the one underneath the covers. You just are calling static methods that might help, but still, I think it's too late still at this point. But that's something that could be done. But you're right, you can't turn off the Java ones, and people are going to use the Java ones. So
the issue I see here is that the moment you are cross publishing and you target different platforms, you end up always picking the semantics of one. In this case, the semantics are those of JVM. So it's up to the implementers of the other libraries supporting the other platforms to kind of abide by the same requirements and try to be as intuitive as possible. Try to not violate any kind of assumption that has been made in Java code, or at least that's the ideal world when it can happen. So I think it's...
Well, no, the ideal way would be if the Scala specification would have been platform agnostic to begin with, but...
Yeah. Ideal world.
Scala specification says anything about standard library to start with, like strings, right? That would be nice.
So I have a kind of proposal. I'm not sure if it's inside or outside the platform effort, but you know, we do something kind of similar, and that's like the MEMA, right? Because when you're maintaining your own binary API, we check against our own stuff in version 1 and then see what's the binary differences. And often it does catch some surprising, like a weird method that you didn't add or added or something like that. So if the community wants to at least, like, you know, make things more JVM parity, current situation is that JVM had like 100% of the power and other platforms don't, basically. And a lot of people are contributing tooling to the JVM. So we have to kind of like gradually narrow that gap, basically, right? So I think something like MEMA, if there were some command line tool or something that you can hook it into SVT or any other build tool, that could be the beginning step that can warn you during the compile time or after compile time, saying your library X, if you want to port it, currently you can't because you have you know, direct reference to whatever bind.xml or something, something like that. Yeah.
Yeah, but that's, I mean, that's tricky because the tool itself would have to know the state of the ecosystem.
Yes, at the moment.
Which is not, I mean, as I said with the question from Lars before, it's not just about the Scala.js core repo. There are several repos out there that are not maintained by us who provide.
Right. That's precisely why I think it should be outside of the platform, and it should be just a community maintained repository. So whoever who wants to make a new JS library can register themselves programmatically in that file, basically saying, okay, I just added this thing. So here, like if it's like well known enough within your native ecosystem or JS ecosystem, you can maintain the list as a program, essentially, as opposed to a website.
Yep. The only problem I see here is that you wouldn't be able to, like, you would have always an outdated version that doesn't consider a certain library to be cross-platform. In that case, it just solve that issue by having some kind of user customized whitelist.
Exactly, just like MEMA.
Telling the user to update the version, or just in the instructions of the library you depend on, there will be like a section saying you should add this like ID to that whitelist, and then everything will be fine.
Well, if every library that provides additional JDK APIs registers itself to the central repository, then that list will always be up to date.
But a central repository, what do you mean? Do you mean
something like Scala.dex, or I mean, it could be a feature of Scala.dex.
Right. So then it would be like a tool.
Too far-fetched.
It would be some kind of tool that would connect to Scala.dex servers, and then it would check if at that moment there is a library or like that library supports increased runtime.
So there are two very, very different parts here. There are the JDK APIs, and then there are Scala libraries. JDK APIs, they're weird because they will compile without additional resolvers because they're in the class files in the class path. So for that, you need one sort of whitelist, which says that portion, like java.time.date formats, exists somewhere and is provided by this library and this artifact that provides it. That's one thing. Those are linked by binary APIs. So for those, you can build the whitelist based on the binary APIs of the class files. That's one thing. And the other one is the Scala libraries, for which the contract across platforms is on the basis of source APIs, not on the basis of binary APIs. And for those, what you would have to say is this artifact has a JS correspondent. And that Scala.dex actually already tells you. Scala.dex is already able to tell you, hey, I don't know, MicroPickle has it's MicroPickle, has a JVM and a JS version in possibly a native version by now.
Yeah.
So that one, the information already exists in Scala Dex. So that one, it can be fetched from there. The other one doesn't exist. So saying, hey, that class from the JDK is provided by that external artifact.
So in this case, you would have some kind of tooling support in which you would allow you would allow the tool to look into the jar and see if there is like a concrete file there.
Yeah,
maybe in the meta-inf
if the class files
directory.
of your
or no, even easier, just
project,
have like a meta-inf directory in which you have like a file saying, I support this platform, so I support these runtimes. And then you will have that enabled by default in every build tool, so that every time you publish, your local jars have this information, and you can tell immediately whether a concrete jar could be used in another runtime. It's basically what Maven plugins do right now.
So are you talking about the JDK APIs now, or about the Scala libraries?
Scala libraries. I mean,
well, I mean, it's already in Scala Dex, that information, so we don't need anything more. Like from that just from the library dependencies in the tool, in the build tool, you can tell, hey, that library dependency, that artifact ID, it has a JS correspondence.
Yeah.
I can tell you that Scala Dex told me. So that's very easy. Or if you use Scala parallel collections, it's going to tell you, hey, this one, if you ever intend to use JS, that's not going to happen because that artifact ID doesn't have a correspondent for the JS version. For the JDK APIs, it's a little bit more complicated. There you have to look into the class files produced after compilation of your project and look whether all the binary references to the Java, to the JDK APIs, whether those are all whitelisted in the central repo.
So that would be something that you guys would do on in your builds every time you publish your JDK implementation.
No, that would be an SPP plugin for a user's build.
But in this case,
check whether their source code would one day, if they want to start cross-compiling it, whether it would be super easy because they would just add JS as a back. And that doesn't exist.
Yeah.
In our builds, what we would have to do is for, say, in the repository for Java time, we would have to, we would have to have a post-processing step of the SJSIR files that will extract the binary signatures and publish the binary signatures in the central repo. So it would be funny because on the publishing side, on the library side, you extract the binary signature from the SJSIR files, and on the user side, you actually read the class files to extract the same binary signatures and then match up the binary signatures.
All right.
But it's possible.
So it seems that tooling,
I can even guide someone who would want to implement such a tool.
It seems that tooling is the kind of answer that we are all converging towards. What is your take on this, Martin, as the person that suggested?
Well, I think tooling would be great. I don't think it addresses the main concern, which is basically that you have like, well, yeah, you have leaking Java abstractions in several places. You will still depend on the same Java artifacts.
You say that is a fundamental problem you cannot solve. Like there are many variables that make it super hard to solve without good resources and lots of will, and we don't have it.
Would it be possible, or even would it be desirable to do this incrementally, like to introduce libraries, like for instance, giving support to as things are doing like right now with JSON, for instance. Would that be possible to do for other things in the JVM as well, or sorry, JDK? Because in that case, you could like partially migrate or slowly migrate away from people using the Java artifacts.
You will have to ensure that there is zero overhead.
But
yeah,
it seems we are diverging a little bit now.
I think
so maybe.
I think I just want to like one more comment is that you said leaking Java APIs. The second you use string, you leak Java API. Like it's impossible to completely have some kind of isolated Scala namespace. It's just not technically possible. And you will never be able to implement string on your own in JVM because it just bakes into the VM. It's like JIT compiler optimizes string concats if they happen in a row. Like you cannot possibly implement your own Scala string, which will not degrade performance. So basically, it's fundamental. Like you cannot not leak. If you do implement some kind of mega API that has everything from the JVM hidden in a very exhaustive way, it will by definition be worse than what's there in JVM. So it just, I don't think it's a desirable goal because it will be worse.
Anecdotally, currently, in the past few months, I have one of my secret goals that has been to improve the Scala JSON AST to make it more specifiable. And the answer to that has been to make it rely only on the Java namespace. So the Scala JSON AST becomes less dependent on Scala and only depend on Java. So that probably tells something about how much Scala is inherently based on top of Java.
Okay, guys. So let's move to the third point because it's the most important one, and we're going to discuss now about the Scala JSON AST. It seems that we've done lots of progress in this point, and I'll probably specify that in the minutes, and we can continue this discussion in contributors in the Discourse instance. So
I'll leave now for Matthew to come in, right?
Awesome. Thank you, Martin. It's been a pleasure to discuss with you.
Thanks. Yeah. Thank you for listening. Bye.
Goodbye. So now we are waiting on Matthew to join. Matthew is preparing now for a release. Yes, I did. I was talking to him. So Matthew is preparing now for a release because we are synchronizing to get a release out soon. Ideally, we'd like to get this release like towards the end of the month. So right now, Matthew has compiled a list of things or questions that he wants to ask us, and also he has described some technical challenges that he needs to solve before an official release, and hopefully we'll be able to provide him some insight on how to solve those issues. One of them is kind of fundamental to the problem, to the Scala platform, and it's the one about like library dependencies, and concretely external library dependencies, and what is a Scala platform module allowed to depend on outside of the Scala platform. So would you mind going ahead and just explaining a little bit about your problems,
Yep.
Matt? Awesome.
Yep, sure. So probably the biggest problem is trying to standardize on a collection type for a JSON object. So the JSON spec has different recommendations on whether maps in an object should be ordered or not. And this, of course, provides interesting questions, particularly if you want to provide an immutable collection type for your JSON object. So the biggest problem is there isn't really an immutable collection which maintains key insertion order, as well as having effectively constant lookup time on a map in the standard library. And if we wanted people to use this JSON AST and they wanted to maintain key insertion ordering, which makes sense even if you're just printing a JSON AST to have consistently the same keys in the same order, then we need to somehow provide this functionality. In the document, there are various solutions. So one is you could just hard code it against a map interface, which means people, when constructing the AST, can provide just a normal map, which doesn't have this key insertion ordering, or they can provide a list map, which has it with good memory usage, but you get ON lookup by key, or the new linked map, which is basically a combination of both a vector and a list, right. Which has overall slowish performance, but has more better constant lookup time on all operations.
So this is the collection that you wanted to add?
Yes, exactly. So, so there's two things. One thing is if I decided to, let's say, just only standardize on map, this new collection doesn't have as much time pressures because you can release the Scala JSON library first and then release this new collection later. And then people who produce the AST can just use this new collection later on if they want. But if we wanted to say that JSON AST, or sorry, the Scala AST will always maintain key insertion ordering, then you have a problem, because if you standardize against list map and someone tries to look up by key, they get ON lookup. Whereas if you standardize on the linked map, which is what I just created, this isn't even deployed or released yet. And there's different also in Scala 2.12, it will probably be an actual dependency, and maybe in 2.13 it will be part of the strawman collections.
The first option is the better, especially because it wouldn't block a release of Scala JSON AST and would allow the user to choose whether this feature is useful for what.
Yeah, so this is fine. Like if everyone, I'm fairly open to whatever decision is being made. So if everyone agrees to just hard code against the immutable.map for JSON object, I'll update this in the documentation information, and then it will be at least quite a bit easier in regards to the deadline.
Yeah.
I
personally think this is the way to go, but maybe some committee members have here some other insight.
I think it's a tricky issue because I think it's good to, maybe we could make an exception in this case, but I think it's good to have the most sort of unsurprising and correct behavior be the default behavior for something that we say is going to be the, kind of go-to solution. And randomly scrambling your order of keys in JSON is something that there are situations where you will not have a very pleasant experience with interacting with other tools, with editing, for example. If you're trying to edit anything by hand and it gets scrambled randomly every time you touch it, it's not actually a very nice user experience. And one of the features of JSON is that, sometimes people do actually edit it by hand.
Yeah.
So I think that we could put off this for later and say, okay, let's just get it in with immutable map. But I don't think that that is what we should desire as the default behavior of something like this. I think we should want the order preserving version to be the default precisely because it has the behaviors that make it as nice as possible. And then if you want it to be the default for that reason, then I think we should have an answer about how we should get there. And to me, that suggests that, this alternate collection type should exist somewhere in the Scala library. Logically, if we want to move it into 2.13 strawman collections because it seems like a sane general capability for collections to have, it seems like it should be a separate module that you depend on for 2.12 and not for 2.13.
Yeah, I especially agree, and I think that in this case it's good to make an exception. I think always the intuitive behavior should be the default, but this is something that first just to get a release out and see what the community reaction is. Just to enable this use case, I think just depending on immutable map is totally fine, especially because it depends on a very, the semantics of JSON depend a lot on the use case, I would say. I haven't used JSON much myself, but I could imagine that this is not something, keeping instruction order is not something that every JSON user wants.
If I can comment on this point, I think Scala is in an interesting position. So basically in every other language, the JSON implementation, if it's an AST or if it's dynamically typed, is almost always a mutable map. And of course, mutable map having key insertion order with all of these properties is fine. It's just a standard hash map. And actually, Scala and Clojure, the two languages here, are exceptional in the regards that it's considered idiomatic to use immutable collections. And this was actually getting to the second point in the document, whether it makes sense to restructure it as having a mutable and mutable Scala JSON AST. So the kind of problem happens is because everyone in the Scala community wants to use immutable collections by default, and by default, the behavior is also expected to have key insertion order maintained, and this is where the contention sort of comes. Like another alternate decision is to provide a mutable and immutable, just like you have with collections, a mutable and immutable version, and kind of the person making the AST would decide. Because right now in the AST design, there's the standard and then there's unsafe, and it's called unsafe because of mutable and for other reasons. So that's just like throwing another point there, is that other languages don't really have this problem because it's considered idiomatic in other languages to use mutable maps.
Mutable and immutable sound way better. How does Clojure work around this issue?
By accident. So Clojure has the same immutable map with tree structural sharing, but they specialize up to 9. And Scala specializes up to 4. So it's still a problem in Clojure, and they also have to work around it by using a normal mutable map. But it just happens by chance. The problem happens a lot less often because maps in JSON usually have less than 9 keys. And they specialize up to 9 because they have more performance problems.
It sounds like the same problem to me.
Yeah. And in Scala, it's the same thing. It's just Scala specializes up to 4. The map has specialization up to 4. So yeah.
I see.
Yeah. So.
Emoji maps, so to force everyone to test for the corner cases.
Yeah.
Okay.
So I mean, I guess it's a difficult problem, especially now that we have like a deadline where we want to make a release. So I mean, the mutable immutable design also is nice. It will have maybe some minor drawbacks, but again, this involved me having to change the design of Scala JSON AST again. And I think we've already had so many rounds of getting people to agree with the current design that we may decide not to do it for now. So yeah.
I think we're in a good position right now, and David Paul has said as well that he agrees with Conrad that immutable map is the way to go, and I also tend to agree with that. Is there anyone here that doesn't agree with it or would like to pinpoint some other flaw in doing this?
Well, so I'm insertion order fan, I guess, because I think in general, any ASTs, JSON or not, I think one of the things that it should be able to do is parse some sort of text and then round trip it back into the text, essentially. Like that's, even though the JSON's spec semantics is not supposed to be guaranteeing the order, when you're talking about the tree, you're actually analyzing the text itself, right? Not the semantics of the JSON. So I think from that perspective, like it's sort of like you can think of it as a referential transparency, essentially, of your collection or your tree as the data type, essentially. So to me, that's a desirable property, and it would be nice, like, I don't know how hard it would be, but it would be nice if we can essentially have one implementation. And maybe it's something that you can plug your particular map implementation afterwards. But I don't know if it is really a good idea to have like safe and unsafe or immutable and mutable, the separation for like relatively commonly occurring data structure like JSON, essentially, right? Like at that point, people may say, okay, let's just use spray or like play or something like that. So that's like, just from the adoption point of view, that's something that concerns me a little bit.
I have a question regarding using the map, are keys, I know no one does this, but I think the JSON spec allows duplicate keys.
Yes. So this is why it's the unsafe. So there's actually two ASTs in the proposal. There's the standard and the unsafe. The unsafe also allows duplicate keys. And it maintains this referential transparency that Eugene was talking about. So it will never lose data as long as it's valid JSON, and you can put have multiple values for the same key. And it will also maintain ordering for this. The structure it uses for this is actually an array or a list. And but it's mainly this unsafe is kind of meant to be used for parsers and for people who have use cases where they have to rely on this behavior. And this is why this distinction was also made. Mm-hmm. So Eugene is actually using a forked version of the current AST's unsafe version for, I believe, SPT's server. Yeah. And he needed this functionality. He needed to make sure that the key insertion order was always correct.
So would it be possible to have this, as we were saying, just with immutable map for the first release and then switch that in a new release in maybe 6 months?
Yeah, I mean, look, this is perfectly possible. I mean, I'm not sure how much of a complaint it is that a lot of the other framework authors, particularly from Spray, which is now aka HTTP, Play, HTTP, Cersei, and what's the other one I'm missing? JSON 4S wanted like one release which was ultra stable and basically doesn't get changed after. So I'm not sure how much of a problem it is going to be to make a next release for these people. It may not end up being such a big problem, but one of the strongest insistence was to have just one release of this library, so as much as is possible. Yeah.
I think it wouldn't be an issue. We have like another release in the future, which is more intuitive for users.
Yeah, but the difficulty is that you have transitive dependencies that will not want to switch over the new version.
Yeah.
So it's a very important cornerstone kind of library that once you have the API, it doesn't break anymore, like ever.
But you could still keep it binary compatible and just add like a new.
Not sure.
There's one question that I would have, just an understanding question. When we standardize on a mutable map right now, that means that the AST structure will just define that interface, right? But where actually in the library are we creating AST node instances?
So this is the thing. It's just an AST. This completely depends on parsers.
Exactly.
The people using AST.
Essentially, the job of what kind of map I actually supply for an object, that is not the responsibility of this library, right? That's delegated to whoever creates it. So to my parser or to whatever. So if I have a parser that I could tell, create hash maps, then it will create hash maps, and I might not have the right order. But if I tell the parser do list maps, then that might be fine. So, and we'll all standardize it underneath this immutable map interface, right?
Yeah, of course. So this is one solution. So, I mean, it's just about making a guarantee. So if you standardize on, let's say, an ordered immutable map, you can always provide a guarantee for any instance of this JSON AST. It will always be ordered. And if you just use immutable map, you can't use this guarantee because someone can produce the JSON AST that is not going to maintain order. Right. So it's just this trade-off. I mean, you can make like a bet that most parsers that will produce this JSON will either have same defaults or provide a nice way to toggle this behavior. But again, this is like shifting responsibility somewhere else.
Yeah, of course. I understand. Yeah. Is there... Are there any points right now in the library where we create nodes inside of this library? Like, for example, when we convert from an unsafe to the immutable variant?
Mm-hmm. What do you mean by nodes? I mean, there are conversion functions there, and it's documented in the library. So anything under unsafe tree, you can go to standard and it will give you the exact same tree as standard, and vice versa.
And at that point, we would, of course, have to decide which actual map implementation we use, right?
Well, actually, I mean, currently it's hard-coded as a map only because I'm deferring being able to construct it differently when we make a decision now. So currently it just uses the map, but of course it can be changed to provide a different way of a different constructor to be used.
Right.
Yeah.
I understand, because like that's I would also be in favor, like Conrad and everyone else, for like moving responsibility or delegating responsibility to the actual parsers and libraries that create the AST nodes. But if we want to do that, we should make sure that we don't kind of, you know, introduce a specific decision on which kind of map implementation it is inside of our library by completely hard coding this hash map, for example, when we convert from an unsafe AST.
So there's I think from what I remember, there's just a default constructor which uses map, which is why it ends up using it internally. Yeah.
I have another question. So regarding Eugene's point about round tripping and getting the same output, what about the number precision? Because I think JSON doesn't specify any precision.
Yeah, so we had a big debate on this. Scala JSON will never lose precision. It actually internally stores a number as a validated string, so validated JSON number as a string. Okay. And then it provides various functions to go to all the different number types.
Okay, thank you.
Yeah.
Okay, great. So maybe it's better just to postpone this decision or postpone the answers that may be left to another meeting, maybe a month. Matthew, does that sound good?
Yeah, that sounds good. So, I mean, I will just leave it as the current map. I'll try and address the construction, because when you go from the unsafe to the standard, it will use the default immutable map. So I'll see if there's a nice way to make this behavior customizable. Yeah, so I'll just keep this decision for now. I mean, the main thing was if everyone, or if we made a general decision that we wanted to guarantee order for immutability, then I would have had to spend time working on my linked map implementation, because it would have had to be hard-coded against this.
Yeah.
Yeah.
We can keep on the technical details in contributors or in your issue tracker.
Okay, cool.
Awesome. So it seems that
sounds excellent.
We have very many discussions today. Let's just continue discussing for like a release and continue to synchronize release, Patrick and Matthew. And for the rest of us, for the rest of you guys, thank you for joining us, and see you next month, I guess.
Okay, cool. Thank you very much, guys.
Awesome. Thank you very much. See you next time. Hey.